And we're live, GM, and welcome everyone to another mode workshop. Today I'm joined by MSFU. He's going to let us know now a little bit more about himself, and ORA protocol, which is what we're going to talk today about, bringing AI to smart contracts, a little bit about what ORA does, and yeah, a little workshop on how to do it. Hey man, how are you? Welcome.
Yeah, thank you. I'm Suning. I'm a researcher at ORA, and at ORA, what we are building is we are kind of like an AI crypto project, and we are building towards blockchain intelligence. And our core technology is called OPML, Optimistic Machine Learning, which is the one of the only framework that enables AI inference to be verifiable on chain. And based on this technology, we built products called On-Chain AI Oracle, which is like an Oracle, but this time is offering AI compute for your smart contract. And also, we built a resilient model service, which enables on-chain verifiable AI inference to be called off-chain. And these are our core offerings. And also, we built an technology called initial model offering. It is a framework that enables the models and also agents to be tokenized on chain. And in this space, we built several EIP standards for enabling this initial model offering to work. So we built some EIP protocols around the verifiable inference asset to make NFTs to be verifiable. And also we built another protocol, another standard, EIP standard that enables on-chain revenue sharing inside the smart contract. And these are what we do at Aura. And happy to do
Nice.
a workshop for Mode Network today. And I will be talking about how developers can integrate AI into smart contracts.
Love it, love it. I like this idea of like oracles that bring AI on chain. It kind of makes sense, and I'm pretty excited to see how the inference works and how you can prove that as well. So yeah, let's then just get right into it. Thank you for being here, and I know people are super excited to see what you have for us today. I'll be
Mhm.
around. I'll be in the background, managing everything. And if there's any questions in the comments, please just leave them there in the comments, and I'll make sure to ask the questions. Or if I get curious about something that you mentioned, I'll probably jump in and interrupt you to bother you a little bit. So
Mhm.
without anything else, just yeah, all yours.
Okay, I will get started, and let me, yeah, let me get started. And so for today, we are going to talk about a lot about crypto AI and especially the combination of these two and the intersection between these two. And so for first, let's give a general like intro to this space. And so for some initial experiment with AI and crypto, a lot of the focus is going from using AI to enable a better crypto-related experience. For example, Vitalik wrote a post last year about having this AI-enabled um, like security screening when people signing the transactions. And because AI has the ability to interpret and also basically exam or the data, which is out of the organized structure. So AI has this ability to basically do all this general compute on offering a better security experience. So this is like one of the early experiments with AI, adding AI into crypto. And another example of the AI crypto is about using crypto to incentivize better AI. For example, outside Ethereum network, we have seen a lot of like individual validator networks like big tensor, they use the crypto mechanism to build a AI network that is incentivized in their own way and incentivized by their own token. And that's like a different scenario um, from the previous using AI to build better crypto. And this one is more about like incentivization and all the economic structure of crypto, and AI people just leverage that to build better models to incentivize their participants to interact with the network and also contribute their computer resources into the network. And for the next one, these are the kind of like the recent one about AI and crypto, which is a very hard combination of crypto and AI. And a lot of the projects, they build their agents and then they run their agents in the basically crypto trader. And then their AI agent will give out information based on the current market condition and also like interact with the on-chain activities and also interact with the crypto community. And for this, they also enables a combination of crypto and AI because they are building a kind of AI project, and this AI project is tied to a crypto asset, and it's basically uh, a kind of tokenized meme on chain, kind of tokenized like AI meme. So I think this type of uh, space, this type of application can also fall into this crypto and AI's interaction space, and uh, they basically use AI to build up the character, and then this character is tied to one of the like the meme and personality of the AI. And these are the three major applications when we talk about AI and crypto. So let's get back a little bit and talk about some technical, like general background about machine learning and AI. So if you haven't heard about AI before, or you just heard about GPTs and all these general applications before, but haven't dived deep into the technical like details. Here's how the life cycle of AI works. So basically, when we talk about AI, we think about uh, companies spending like millions of dollars to just train one model, to train one like ultimate model, for example, DeepSeek R1, and they spent all this money into the computer resources and also the data and also the GPU resources to do the training. So this training is basically you take a lot of data and then put it into uh, somewhere, and then they will do the training to make sure that this final output model is in the is able to extract and analysis and also interpret data, and the final output of this training phase will be a kind of a kind of model with different ways with different with a matrix that can predict new data. For example, in your training data set, you have the strawberry and also bicycle, and then in the training phase they will make sure that if someone putting strawberry as the input, it will output. They will know that strawberry look like this, not look like the bicycle one. So this is based on the training data, and for the inference space, it's more about prediction that the model will not encounter data uh, exactly the same as the training phase. So it will be input some unpredicted values or unpredicted data, and then with this trend model weight, they will basically do some prediction or do some classification. And for example, if we take GPT as an example, uh, GPT takes users' queries, and based on this users' query, they will basically extend and continue generate the tokens or to continue generate the text, and this process is called inference. And for our today's workshop, I will be mostly talk about inference, and where we mention about like on-chain AI and also integrating AI, we are mentioning about the aspect of inference. So this is uh, kind of what we are talk about today. Um, and for training, it's a different kind of uh, process because it's already taking a lot of compute resources. So if we want to make it on chain, then we it actually requires more and more uh, like technology and also more advancement and accelerations in terms of all the algorithms. So today we will be focused mostly on inference, and inference is how you build applications. Because when you're building an actual application, you just need to uh, like process with the inference phase. And let's continue. So you probably have seen a lot of off-chain AI examples, especially AI agents tweeting on X. And these AI agents, if you put it simply, they are essentially an off-chain GPT wrapper, and how they tie the model with the like AI agent, how they tie the token with the AI agent is that they basically do it based on reputation. Like for example, the AI agents will put their put the country address in their bio, and then you know that this AI agent is pretty intelligent, and this AI agent have this CA on its bio, then it's probably performing pretty well in terms of the token value. But this kind of off-chain AI actually hinders a lot when we want to build something on chain, or we want to build something more meaningful other than just a like a reply guy on Twitter. So for achieving kind of this on-chain AI, um, we would actually need much more to make sure that this AI is connected with the actual on-chain space, with the actual on-chain world. So for the applications of this on-chain AI, we will talk about that later, and how we enable it. We will also talk about later. But from the very start, when we think about having on-chain apps, we will need to have these type of like um, characteristics. So first, we kind of need the on-chain dApps to be able to interact on-chain. For example, a smart contract, it can interact on-chain with all the EOA, with all the um, users. And the second one and also the third one, they are kind of like a combo together. And you need this kind of verification of the operation, and also you need kind of a proof of computation. If we take Ethereum or take any layer 2 as an example, the verifiability and also the proof of computation comes from the decentralized consensus of the network. And also, if we take L2 as an example, it will be the ZK proof or the for proof of this whole rollup, so that they ensures that the smart contract is actually um, like connected on chain. And for enabling AI to be on chain, we also need these type of tools, or need to fit all these characteristics to make sure that this thing is equivalent to smart contract. And for enabling this on-chain AI, we actually have seen a lot of these approaches, and let's get to it one by one. So the first one is called ZKML. ZK has been a very popular technology since like 2 or 3 years ago, but mostly what they do is that they use ZK to build generate proofs for EVM computation, and this is also applies it's also applicable to AI space, because AI is essentially, when we talk about inference, they are still kind of one special form of computation. And so we have seen pretty much a lot of projects like uh, maybe take WorkCoin as an example. They use zkML to build um, the to generate the proof for their like recognition algorithms. And for others like modulus labs, they're trying a lot more things closer to on-chain AI, that they use EKML to build um, like a on-chain bot that you can versus the word, because it is like an on-chain bot that generates the proof for your for its like chess moves on chain, and then as a user you can play chess against it, and to know that it is an actual AI, it will offer the proof for you, and all these proof are verifiable on chain, so that you know that the move is made by AI instead of like an actual person behind. And for ZKML, we will also talk about the some of the blockers of it, because when you think about ZK, you actually think about like something similar to the model training, because it takes a lot of compute powers. You need to have a very beefy server to actually generate those proofs. So it is kind of like not decentralized enough, or not having the best performance for the scenarios that we are going to talk about in the later slides. And the second on-chain AI approach that we have is what we created called OPML, Optimistic Machine Learning. And it is basically kind of like an OP rolled up version of the verifiable AI. And it is instead of basing on the cryptography proof of machine learning inference, we use something like game theory for enabling this machine learning inference to be verifiable. And we're gonna talk about more about the details of it. And for the third one, we have seen that on many decentralized networks, that for example, if we take big tensor as an example, then BitTensor kind of also fall into this crypto economic approach, but instead of enabling on-chain AI, they are enabling separate network. But we have seen a lot of like attempts on this, like EigenLayer. They are building something similar to this stake weight voting for machine learning inference. And for this one, they are enabling like uh, a standalone decentralized node network, and then this network is basically governed and also secured by validators. But this is kind of like not the most decentralized, or not the most verifiable way to enable this on-chain AI, because when you have a large number of like validators, the cost of verifying all the signature on chain is still not that efficient, and also the decentralization level of this crypto economic network is based on the number of nodes. But for the number of nodes to be increasing, it will also um, waste a lot of like compute resources, because for every AI inference, it will take like pretty much a lot computer powers. And these are the three on-chain AI approaches on the market right now.
I got a little question there. This is great. Actually, seeing the three different kind of on-chain AI approaches is great because I think the space is quite new. So trying to define and categorize these kinds of things is really useful. You mentioned B-Tensor, and we are building a subnet for B-Tensor called Synth that it's already live, basically predicting BTC prices. What I just wanted your opinion on like BitTensor in general, like their model, because I like it very much. Like I kind of like the way they improve the subnets, the way they assign weights, and the way the miners and validators work in general. Like I think it's a pretty cool system. But yeah, wanted to hear from you, like, what do you think, like personally, about the design they have and the way they've structured and decided to build their system.
Yeah. I think BitTensor is really one of the only, or one of the, I think the first networks that enables the actual execution of the decentralized AI network to be uh, like a reality. And I think they are their design is pretty like pretty much like Bitcoin style, that they have a lot of like components around the mining and also the like the emissions and all that. And when we talk about like on-chain AI, I'm more about like Ethereum on-chain AI, but for BitTensor kind of networks, they are also a blockchain, of course, but they are more like having a flavor of the compute network. And I think as a compute network, BitTensor's subnet architecture really uh, sparks a lot of like new applications, because each subnet they have their own like specialized model and also specialized feature. And for these subnets, they really does a like a pretty good categorization of different technology, different algorithms. And what we see about AI and also the trend of the AI is that all this AI will be more like specific, or more domain specific. And I think Bitensor built up a very good framework or scaffold for all these like incentivization mechanism to be working. And then what people can build is that they build their own machine learning algorithm, or they build their own training mechanism, and then they can take that into Bitensor. And Bitensor as a like a scaffold, they can like providing the foundation of all this decentralized AI can be working. And also it attracts the node operators to contribute the compute resources. So I think that's how they use this crypto economic approach to offer the flexibility for adapting to different models, adapting to different like business models, and also the um, different roles of the validators, and the different kind of setups of the networks. So I think that's how crypto economic approach works, because it's very easy to bootstrap, and also in the process of bootstrapping, they can be much easier, because they only need a node software. They don't need to like build up an entirely new um, like zkML algorithm or OPML challenge systems to start with. So I think yeah, it's all about flexibility.
No, that's a great take, honestly. Thank you for that. Mainly because like we also discuss about AI agents as well, so like an application of AI in and crypto. And I think the same. I think AI is going to tend to have very specialized models, and it makes sense because we're going to like training models is going to be cheaper, is going to be more available each time, and a more specialized model and trained specifically for something like with a reduced domain will give you better answers and will be just better in general. So I'm intrigued to see more systems that work on the coordination of different models and how they in like how they exchange information, and probably like that's why I think crypto is really good for AI because it's really easy to exchange tokens and have this programmatic money layer managed by AI. We'll see if that happens or not. But yeah, I think
Mhm.
BitTensor is a really cool experiment showing how this can be done. We'll see later how subnets connect with each other if they need to. Yeah, but yeah, thank you for the answer. I'll let you continue. Awesome.
Mhm. Yeah. So let me move on to the next one. This is about the comparison between OPML and also ZKML. And what we see in the limitation of ZKML is that you need a very beefy server to generate the validity proof or the ZK proof of each model machine learning inference. So for some reference, one ChatGPT GPT inference takes around like 200 milliseconds to response. But if you use ZKML for outputting your inference and also generating the proof of inference, it actually takes, I think the latest benchmark from last year is it will take 2 years, 2 days, sorry. 2 years is too crazy. 2 days to generate one inference for the GPT-2 model. So GPT-2 model is kind of like obsolete in today's market, but you still need like 2 days to generate just one inference of the model. So that's kind of limited because if you cannot use the latest model, you cannot like actually build the most modern application or maybe the application that with the best performance. So it doesn't really make sense that you still use GPT-2 model and in today's market. And also for this GPT-2 model, you will still need to suffer from like 2 days to generate just one inference. So imagine if more transactions, more volumes come into the application, it doesn't really fits if you use ZKML. So, but what we created around OPML is beyond that limitation because um, it's just like OP rolled up compared to ZK rolled up. That OP rolled up is much um, kind of like faster because it doesn't really need the um, proof generation process. It only need people to challenge. Uh, Let me move on to the next to run inference, and then if it is challenged, it will kind of performing an on-chain arbitration process to generate a fraud proof, and then this fraud proof will be serving to provide validity for if this computation is correct or this computation is wrong. So the proof generation only happens when the data gets challenged. So ZK is assuming everything is wrong, so they generate proof for every like computation. But for OPML, it's more economic efficient because it only generates when people are disagreeing on certain computation. So that's um, the technology we built, and for this one, it also involves a lot of like adaptation from the existing OP EVM system into the OPML system. So the full version of this OPML will be released soon, and currently you can search for OPML optimistic machine learning on search engines to see our paper on archive. And based on this OPML technology, what we built is called on-chain AI Oracle, and shorter form is called OAO. And it is kind of like an Oracle powered by OPML, and it supports the models from DeepSeek R1 to Stable Diffusion. And right now we support around 30 AI models, and most of them are language models, and some of them are text to image models, and image to image models, and text to videos models. And this Oracle is very similar as a pool-based model. So if you work with Chainlink Oracle before, then you will notice that a lot of the products in their ecosystem is like push based. So basically, you have your smart contract, and your smart contract subscribes the Chainlink Oracle, and then this Chainlink Oracle will like um, basically push the data on chain to like periodically, and then you can access that value on chain. So this is kind of like the push-based Oracle that works very similar to subscription. And our on-chain AI Oracle is more like an pull-based Oracle, which is every time you want something, you will need to like send a request to our on-chain AI Oracle, and then for this individual inference, you will get your response based on the inference request. And so this is kind of like every time you want some data, you pull the data from the Oracle. And the Oracle is kind of like a combination of the concept of an on-chain AI Oracle contract and some off-chain nodes running to power this Oracle to actually run the AI inference by themselves, and then they push the data onto the on-chain AI Oracle. So this is how it works. And for the node, for running the node, we are having the node software called Torah, because it's written in TypeScript, so it's Torah, which is kind of similar to what Ethereum has Geth, and that's like the general architecture of on-chain Oracle. But for developer, if you wanna like build apps, you just need to know that on-chain Oracle is a pool-based Oracle, and every time you want AI inference, you just send your prompt, like all the prompt settings, and then the model ID to the on-chain Oracle, and it will give you the um, calculation result of this AI inference. So to integrate with on-chain Oracle, that's like a code the core code to code it. So basically, you will call this function of calculate AI result, and by this functions, you will need to pay the model fee, and then you specify the model ID you are using, and also the prompt that you are using, and then you send a request to the AI Oracle, and you will also write a callback function to receive the request from the AI Oracle to actually like use this AI inference result on your smart contract or on your application. And here's also some tips, some information about using on-chain Oracle on different networks. So right now, OAO is deployed on around 15 networks. We have deployed on some like test nets, and also, of course, mainnets. We are deployed on Ethereum, and also major L2s, including Mode. And for each deployment, we have offered the on-chain Oracle's smart contract address, the Oracle contract itself, so that you can build your own application, and then this your smart contract can be integrated with OAO, and then your application or your contract can handle the logic inside itself. And for each deployment, we also additionally offers the prompt contract. It is kind of like a minimum implementation of integrated with OAO that you can just directly use the prompt contract to build up your own like AI apps. For example, if you just need to use prompt engineering and you don't really need to do some uh, advanced features, for example, like um, using multiple models inside one inference core, or having different models to having the synergy with each other, kind of like a multi-agent system, then you can just use this prompt contract. And this prompt contract, you can connect the prompt contract with your maybe your front end application, and then you can only you can just code it with different prompts to get different on-chain responses, and then you basically don't need to uh, have the uh, experience to write smart contract to build with on-chain Oracle, because we already write one this prompt contract as the minimum implementation, and you can just connect with the implementation and to build your own like application with only a front end. So that's kind of like no need on the smart contract development or the smart contract deployment, and you can start with the on-chain AI. And for also another tips when you are integrating with on-chain AI Oracle is that we have offered uh, like 30 around 30 models, and it has like two types. One type is the native models that they are run directly inside the Aura node network, and including Llama 3, Stable Diffusion version 3, and also other like major models. These models are running natively, so we have assigned like a distinct model ID to them. And for example, llama is 11 because the two starting else at the very start, and SD stable diffusion is 50 because the it's like a digit representation of S, the alphabet S and D. And we also have external models, and these external models are not run by the Aura's node network. So for these external networks, external models, we'll need to do some a little bit of conversion to get the model ID. Here's a Solidity code to get the model ID, and you can also calculate it inside your JavaScript code, maybe in front end or just the script. So this is also another tip. And these are the previous knowledge about how you can integrate with on-chain AI Oracle. And right now we can think about what's the grounded application for on-chain AI, so that it will give you some hint about what you can build with OAO, or how you can integrate AI into your smart contract. So the image here illustrates the like a, kind of like a cycle for infrastructure and application. So I think the previous past year is more about infrastructure of AI crypto, because we have seen we built something like on-chain Oracle and also resilient model service, and also other projects. They build some kind of AI agent frameworks, and these are great foundation for the infrastructure of this AI model or the on-chain AI to be thriving. So we see that the next big move will be around the application of the on-chain AI. And here are some like application we think about uh, for you to build. And the first one is initial model offering. We have briefly talked about it at the very start. And I think the trend of this cycle is more about tokenization. For example, Pound Fund is tokenized meme, and DAO Star Fund is tokenized fund, tokenized DAO, and Virtuals is tokenized agents. So what we think about IMO or initial model offering is about tokenizing AI models on chain since AI models are on chain already. So it's basically you have this model, and this model is integrated or included in our on-chain AI Oracle. So for every call to this model, it will generate model fee, and this model fee can be shared across the token holders or the users. So that's the basic idea of initial model offering is that you tokenize one AI model on chain, and then you can share the revenue of it on chain with the user. So to build applications around the initial model offering models, you can basically receive kind of like a rev share from the model itself. So it's actually provide like more options for you to build around the model because you can have this model uh, like originally it will have some kind of revenue stream, and if you build agents, it will be kind of like a derived asset of this like revenue generating model. And so um, you can basically look into more about initial model offering and the models, and choose to build with these models at the very first place if you want to integrate with on-chain AI Oracle and integrating AI into smart contracts. And here's a question about like, does IMO have to be on-chain AI? Because we want to like break down each application and to find the most fitting one, or to find the most like make sense one that we want to build with on-chain AI. So on-chain AI, what it does in this application scenario is that it helps tracks models revenue and usage on chain. But if we really think about it, most of the revenue of the IMO model come from the off-chain settings. For example, like Grok model, they are like entirely generating value inside the Twitter subscription, so that they don't really generating revenue on chain. And for most of the model, they are also doing it this way. Um, and also we see that without the standard or without the EIP standards that we set up, the revenue can also be shared in a less decentralized and less verifiable way, but it still feels okay because all these revenue are coming from the off-chain settings. So when we really think about like IMO, does IMO have to be on-chain AI? We think that IMO can be can be working well with on-chain AI, but it's not like the killer use case of like integrating AI into smart contracts. And the next one is about AIFI, which is like an older version of or what we pictured way before Dev AI becomes a term. So it's basically about replacing the computation component of DeFi protocols with AI as the processor. So, for example, when we look at one AI, one DeFi protocol, we will see that it offers one kind of key component to compute uh, as the like a core feature. For example, an AIM, it will have the like XY equals to K curve to compute the price for you, and that's kind of like the core computation component of it. And for the aggregator, it will calculate the best route for you to performing a swap. And for lending protocols, they will basically calculate your shares into the pool, and also the revenues you are generating, the interest you are generating from the pool. And you can also borrow assets, and this lending protocol will calculate based on the collateral rate for you. And these are the core computation components. And for every computation, because AI is kind of like a general compute computer, then you can use AI to replace um, all these like hard coded values with AI algorithm. So, for example, you can use AI to calculate or having this kind of dynamic curve and fee to build like a new AI AMM. And for aggregator, you can use AI to aggregate all the sources of the quotes, and you use AI to more intelligently to know about like the potential MEV value or the potential extra fee coming from this transaction, this swapping. So AI can be more intelligent when we actually find out the way to replace the computation of these DeFi protocols. But if we think about does it have to be on-chain AI? Um, it actually helps to achieve complex compute of the protocol, and also it offers a way that has the verifiability in the system. But when we look at like some specific examples, it's actually not that easy to integrate with on-chain AI, because some of the examples can be implemented by new protocol. For example, the dynamic fee can be done with the Uniswap v4 hooks, and also like for certain applications on-chain like on-chain quant fund or other application that requires like specific trading logic, it will also be a factor with the privacy. But for our OPML, we need to enable this visibility of the data. So it's pretty hard to like build up a perfect AI application with our on-chain AI powered by OPML. So what is kind of like the killer use case of integrating AI into smart contract is, I think it is about judgment, and it is about um, like uh, analyzing the output or the decision on chain. And we have seen like a lot of the AI application is more about persuading the AI to do something, and also letting AI to be a judge on chain. And this can be combined very well with applications like prediction market. Like prediction market is about betting on the decision, and if the decision is correct, you get the money. So this decision process is actually very um, close to how like a system can judge on the correct output, correct condition. So how does prediction market like Polymarket work is that they have conditional token inside this system. And for this conditional token, it will be like having an oracle to report outcome to the each condition. And if one condition is correct, then this condition basically rocks all the other conditions money. And Polymarket is using UMA Oracle to do it. So if the dispute actually happens in the UMA Oracle, then they will vote. But this is not a very decentralized process, because if you actually controls most of the circulation of the UMA token, then you can basically revert one condition. So it's kind of like a reorg attack of the whole system. So it can be do pretty well with the AI Oracle if AI Oracle can be a judge on chain. And when we look at like actual disputes, we can see this example like will Elon step down as Twitter CEO by a certain date. But if we want to put into the prudential market to be one of the condition, then this condition will be very hard to analyze because we need to have like a very hard definition of like what's step down and what's the time frame. Like for example, if he stepped down at the exact day, does it count? Or if the announcement goes first, then the actual step down happen, does it count? So we need to have like an objective on-chain AI to like determine the true outcome for these type of applications because they are objective enough. They can be like a neutral agent because they are not the ones that are um, in stake of, for example, the UMA Oracle ecosystem and not in the um, like betting parties, so they can objectively determine the true outcome based on their like their trend uh, uh, instinct or their like their like their judgment. So this is one of the like most promising applications that we think that we notice when we are working with like builders using our chain AI Oracle, which is about using AI to be an objective like judger on chain. So for example, if we extend from this application to other scenarios or other like specific examples of application, we can think of something like a fear launch mechanism that we actually built that before with other projects that you can use AI to be a judge to judge the allocation that you will get the from a token launch. So it will be more fairer because it doesn't have the all the process of whitelist or something like that. And that's kind of like the extension of this idea. And also, you can build up something that use AI as a gatekeeper of a wallet. For example, you need to like persuade this AI so that it will give you the key to some wallet with the value. It's kind of like a like puzzle or a bounty hunter. And these type of applications, we think that they most make most sense with the uh, like on-chain AI and also integrating when we are working with these type of uh, like on-chain AI scenarios. And when we look at it, does it have to be on-chain AI? We can think that it really needs to be on-chain AI, and also the only way to like manage to do it is about having on-chain AI to be part of it, because as the example that we talked about previously, like prediction markets and also the on-chain gatekeeping and also applications like the fear launch we talk about, they are all on-chain, and all these assets, all these values are also on-chain. So you really need a neutral agent. Um, for example, of course, AI to tell who wins or to tell um, who gets the price. And also, when we look at the privacy concerns, we think that uh, the data, because all these applications are on chain, they are natively public and natively publicly available. So this also offers like smooth integration with OPML because it requires data to be on chain and available. So for the third one, the It also works pretty well with on-chain AI because the inference process is also deterministic, and all these applications require these to be deterministic because you you wanna like have like a final outcome for all these bets or for all these uh, determined values. So it works pretty well with the OPML system that we built. And this is one of the core applications idea that we can think about with the on-chain AI. And also, we briefly mentioned about resilient model services at the very start of this workshop. And because we are kind of uh, like finding our path to the on-chain AI application, um, we will also like offer some infrastructure if people doesn't really want that complex or that kind of quote unquote on-chain application. We also offer a service called Resilient Model Services (RMS), and it is completely okay and suitable for off-chain scenarios like agents. For example, you just want to build like another AI XPT, and then you can use resilient model services instead of the on-chain AI code that we talk about. Because if you just want to talk with the just want to talk with the agent on Twitter, then it doesn't really have to be on-chain because it doesn't like touches the money on chain. It doesn't require the data to be verifiable and doesn't require the inference process to be deterministic. So you just need one kind of like traditional AI service, and that's what IMS is more about. So basically, it's very similar to Together AI, but the advantage is that it has the best support for models in the AI crypto space. It supports 30 plus models, and we are launching more AI models in our service. And the next one is that it has the on-chain payment. So basically, for using this resilient model service, you will need to pay ORA token for the payment. And because all assets or transactions are on chain, so it doesn't have any like sneaky subscription or these like credit cards or foreign transaction fee. So that's another like feature for IMS. And also because we are building it with the like um, decentralized network that we already have for the on-chain Oracle, so most of the compute power will coming from this network that we already bootstrapped it. So the RMS will have a very competitive pricing. And if you look at it right now, it is offering the cheapest DeepSeek R1 model inference of among all these providers. And these are some of the advantage of RMS. Yeah, I think. Do you have any question?
Yes. This is great. I actually love the whole AI as a judge. My brain just faded a little bit thinking about all the possible use cases and the drama on crypto Twitter trying to solve their differences with an AI. I think it's actually a pretty cool one that we could explore. There is a question in the comments that I don't know if you'll know it or not. But it mentions that in another Aura video that Aura helped the Virtuals protocol team build their platform. If this is true or not, or if you can confirm or not, if you know anything about it.
Yeah, so we are working very closely with the virtuals before, and our one of our like team member is like also working with the virtuals, so that's why we are like very close project to each other, and we had announced the partnership I think like around like 1 year ago before virtuals like like the coming to the center of the
Yeah.
crypto AI field. and we are building like things very early before like every AI crypto stuff come up. And they actually, the idea or the concept of the agent launchpad is centered around the concept of initial agent offering. And this initial agent offering is like derived from the concept of initial model offering. And uh, I think um, we announced this concept in of initial model offering like last year's East Denver, so exactly 1 year ago. And building from this concept, we saw that Virtuals actually did a very good execution on realizing that into like a tangible product, which is their launchpad. And I think that's how we like help each other, is that we build up this concept, and then they um, uh, also using that philosophy to build their own platform. So that's kind of like the connection between the two projects.
Awesome. Thank you for the answer. We're close to the hour. So feel free to continue, please. But
Yeah.
just so you know. And one last question from Ace is asking if the Aura team will be releasing any AI agents yourself, or just to showcase the full capabilities of Aura protocol. As I understand as well, Aura is main focus is not agents, right? It's more of like crypto and AI and like much broader use cases that other than like agentic design. But yeah, would love to know your answer to that.
Yeah. So it's actually a very good question, because we do have a lot of incubated, or say like helped a lot of agent projects to be created. And for initial model offering, we offer we basically tokenize altogether three models. And for these three models, they are powered. They also the project itself, or the model team itself, also build up their own agent based on the model. So the the first agent that comes from the initial model offering frameworks is called BRM. It's like a Buddhist agent that can spread philosophy, and also spread tell the fortune for a token. And you can look it up. It's I think it's you can just search BIM, and you can find several agents about it. And also the other one that we tokenized the model, they have the agent for creating basically Sora level video generation for you on Twitter. It's called model, and Kumo spells like KUMO. And it is another agent that coming from the concept of initial model offering. And another major one is that in our ecosystem, we have a launchpad called Palm.ai. And this Palm.ai platform has launched a lot of like agents, um, because it's basically uh, like an AI version of Palm.fun. And for all these agents, they have the ability to chat with you in AI, and they are powered by Aura's resident model services. And I think that's it for the agent part. And yeah, Buddhist agent. And
Perfect.
these are
Yeah. Oh, I just put in the comment of Ace saying thank you, and this was one of the best Aura streams that he's seen. So thank you, Ace, for watching and for the support. If you want to just continue with the what we you were talking about the presentation, I'll just remember we're on the hours so that people don't, the attention these days is a little hard to keep. So yeah, that's all.
yeah
I'll let you continue.
yeah
Thanks for answering the questions.
these are like the last slides. And we talk about RMS, and that's how you integrate with RMS, is that you get your API key at rms.aura.io, and you can just deposit your Aura into um, the account, and then made a transaction to transact the Aura into the protocol, and then you can get your API key, and all the calls and all the usage are record basically on chain. And here's how you use IMS. And it is completely off chain. You don't worry about like integrating with smart contract or integrating with um, the on-chain stuffs. You can just build a like a simple Web2 application, or you can just use this API into your maybe ELISA-based agent, and or also it is working pretty well with the Web2 traditional software world. That you can just use our platform to get the best pricing of the models, and that's it for the IMS. And here is the last slide about all the like crucial links about Aura. And to recap, our core technology is OPML. It is optimistic machine learning that generates verifiable on-chain AI inference, and that's I think on the market it's the only possible way to make all these large models to be on-chain. And for the other tools, they are developers. You can take a look at the uh, dev docs of on-chain AI Oracle and also resilient model services. And that's it for my workshop today. And hope you can build something very exciting with our infrastructure. And that's the end of my talk.
Awesome. That was amazing, man. Thank you for the whole complete picture. You've not only covered Aura, but also like the different approaches of crypto and AI and how to bring AI on chain. So that's pretty cool to see because a lot of this stuff is pretty new. So it's good to see people that have been doing the research for quite a while, naming stuff, to share the things that you guys have been working on. So yeah, thank you very much. You have the links in the screen right now. I've shared Aura's main website in the comments as well. And if you want to reach out to the Aura team, just let us, the Mode team, or the Aura team know. We'll help connect you, or just join their Discord. I guess you have a Discord for sure. So yeah, you know where to find us. This was a great experience, and thank you very much for joining us today. Yeah, any last words?
Thanks, everyone.
Thank you, everyone.